All right, folks, let's go ahead and talk about proportional relationships with equations. We're actually going to be looking at all 3 pages of these notes today. And so we're going to be focusing on proportional relationships with equations, identifying those relationships with graphs, and also identifying those relationships with tables. And when we identify proportional relationships, we're really talking about what are you doing to get from X to Y when we're looking at those specific ratios, whether that's in a table, a graph, or written in an equation. And so that's what we're going to focus on today. Let's take a look at our learning goals. So I'll slide up to the top here. And we are going to identify proportional relationships in tables, graphs, and also be able to find those constants of proportionality. And so we're going to be taking care of actually 47, 48, looking at some ordered pairs on a graph, and also identifying proportional relationships and find constants of proportionalities in equations. So 47, 48, 49, and 50. And so if we look up at here, the tables one is 47. The graphs one is 48. The equations is 50. And then 49 is specifically looking at the graphs as well. So we have 48 and 49 here. And then we'll say 51 for our last lesson later. So let's go back down to our notes today. I actually want you to head to the equations one first. I think you can better understand the other ones by understanding this equation. And we are going to make a change here to something that I find a little bit more accurate in the world of math. So remember that a constant of proportionality is just a fancy name for what are you multiplying by X to get to Y. Okay, what is that number or your multiplier? And so our equation is going to be, and I want you to change this to a K. Y equals K, which is going to represent your constant of proportionality, times X. And so you can see here, what times X gets you Y, and that's what we're trying to figure out, okay? And so when we look at this, our Y, if you draw an arrow here, this represents something, and our X represents something. So our X is what's called our independent variable. And this means that this is the thing that is consistently happening first in our scenario, and then a multiplier happens, and we get Y out of it, okay? And so Y is our dependent. So it all depends on whatever X is, okay? And then K, right here, is what's called our constant of proportionality, okay? It's our multiplier to X. And so the equation for constant of proportionality, if you write it in fraction form, is always going to be Y over X. And here's why if you look at this. So Y equals K times X. If you wanted to solve for the constant proportionality, we would divide X by both sides. And you can see that would cancel out, and we end up with Y over X, just like we're showing right here. And so that's what you want to remember when thinking about constant proportionality. If you just know what Y and X is, if you do Y divided by X, you will get the constant of proportionality, okay? All right, so let's go ahead and continue looking at constant of proportionality regarding equations. So here's some word problems for you. You have David is trying to save for a new dirt bike. He saves the same amount of money each month. So you know there's this repetition and sort of proportionality that exists. By the end of the 4th month, he saved this amount of money. So you sort of just have to think, what is the independent thing? Or if we're thinking a X and Y, okay, what is the thing that has to happen first so that then the other information can come to light? So in my head, we have to know what month it is to then know how much he saved. And so our independent variable for this one is going to be M, okay, for months. And then depending on the months, that will tell us our saved amount, okay, or in this case, S. And so if our independent variable is X and our dependent variable is Y, we know that the equation, not an R, K, our equation is Y equals K times X, or if we divide X by on both sides, we just end up with Y over X. And so you actually know what Y over X is. Okay, our dependent variable Y was 92, and X was 4. Okay, and so those two things equal K, our constant proportionality. So you can just do 92 divided by K, if I have my calculator. 92 divided by 4, sorry. And it'll tell us that K equals 23. And so I know my constant of proportionality, K, equals 23. Okay, and there we go. Okay, and so that's how you use the equation to solve. All right, so let's go ahead and look at this next one. There's an ant in Mrs. Lindenberger's classroom. The speed of the ant can be determined by this equation. Okay, and so here's the equation we're looking at. Okay, I is the distance in inches, and S is the amount of time the ant travels. Okay, and so thinking about that, I'm going to get rid of my R here. Thinking about that, I have to think on a graph with X and Y. Okay, what is the thing that happens first? Well, the thing that happens first is the amount of time the ant travels, and so that is our X. And then Y, which is I, creates a certain distance. Okay, so in 2 minutes, a certain distance happens. In 4 minutes, a certain distance happens. So that's why I'm choosing S to be my independent, and I ends up being my dependent. Okay, so that means the distance he travels depends on how much time he's moving for. And so my independent variable is going to be S, which is time traveled. And my dependent variable is going to be I, which is distance in inches. Okay, all right, and so we know the equation is Y equals K times X, because we're wondering what times X will equal Y. What is that multiplier or constant of proportionality? Same type of thing. So let's go ahead and solve this equation. Remember, if we divide by X on both sides, that's where we get our equation of Y over X equals the constant of proportionality. So all we have to do is plug in our information. So let's plug in Y and plug in X. For this one, Y is going to be I. So let's look. And X is S. And they actually already leave us with the constant of proportionality for this one. So if you recognize that equation, you didn't even have to do anything. And so our K in this case is 0.025. Okay, so this is our constant of proportionality, meaning that's what you would multiply times x to get y's. All right, so now that we understand the equation, let's go ahead and apply that to our other pieces here. So let's go to the tables, okay? And we're gonna look at that same kind of understanding with these tables, okay? And so as we look at hours and miles on this first one here, okay, I have to think about what is x and what is y, okay? And so I know that when I go a certain amount of hours, that will turn into a certain amount of miles traveled. So this is going to be my hours, which is going to be my independent, and miles is going to be my dependent. So we know that the formula for constant proportionality is, let's go ahead and write it down here for equation, is y equals the constant of proportionality times x. Okay, so what are you going to multiply x by to get y? And so this is something we've been doing for a long time with proportions. So we're just looking at like the number 2, for example, and asking, well, 2 times what gets me 13? And so you know that you could do 13 divided by 2 to find that multiplier, or another word for it now is constant of proportionality. Okay, so notice that also does what we've been talking about, which is 13 divided by 2, which is y over x, like we've been talking about is the formula for finding constant of proportionality. So it's nothing really different than you've been doing, it's just some different language, okay? So let's go ahead and solve these out and find the constant of proportionality. So the first thing I want you to be aware of is that both of these tables start with an origin of 0, 0. So this is sort of important to know, because for something to be proportional when we're looking at a graph, it has to cut through the origin 0, 0. So this could be proportional. Let's continue and check all of these other points. So the next one, we're doing y over x equals our constant. So let's go ahead and check it. So 13 divided by 2 equals k. What is 13 divided by 2? Okay, so 6.5 is our constant for this one. So let's go ahead and check the next box here. Okay, so we're going to do our 26 over 4 equals k. 26 divided by 4, let's check that multiplier. This is 6.5 as well. Okay, let's check our y over k for the next one. So 32.5 divided by 5. There we go. So this also has the same multiplier or constant of proportionality. And then our last one, 45.5 over 7. Okay, we're just doing this y over x equals k. Test this out. And we also get 6.5 equals k. So since our multipliers or our constant of proportionality are the same for all of these, okay, and technically, so that means they also have the same unit rate. These are all proportional. So this is a proportional table. So is the relationship proportional? Yes, because the constant of proportionality, COP, is the same for all ratios, okay? And so let's go ahead and just fill out and identify what was our independent and what was our dependent variable. So our independent, okay, was x, and so that is hours. And our dependent variable was miles. The miles depended on how many hours we went. And then our constant of proportionality was 6.5, okay? All right, let's go ahead and take a look at the next table over here. And it's already saying not a proportional relationship. So first thing I notice, it does have the origin of 0, 0, but let's go ahead and see if this graph would be a nice straight line. I know that this one, if I laid out an x and a y, it starts at 0, 0, and it would be a nice straight line going all the way up because the ratios are all the same for each data point. Okay. This one, though, if we have a graph with x and y, it does start at 0, 0, but my guess is it is not going to be a straight line. Okay, so let's go ahead and check it out. We need to identify your independent and dependent. Okay, because we have cost, I always know that cost is going to go on top, and so depending on my cost is dependent on the pieces of candy. Okay, because remember, we know that we always do cost over the other information, so that means this is y and my other is going to be x. So here's my y, here's my x. We can go ahead and label that. So that means my independent is pieces of candy. Okay, that's going to be my x. And I know my dependent is cost, and that is my y. Okay, so let's go ahead and test these out. Remember that obviously 0 divided by 0 isn't going to do anything, but let's go ahead and set up our constant proportionality. So we're testing what is the multiplier from x to y. And so our original equation, just to remind you, is y equals constant proportionality times x. So what times x will get me y? Okay, so I'm running 12 times something equals 0.6. So you know that you would just do 0.6 divided by 12 to find that constant of proportionality. Nothing we've done different. Okay, I'm going to divide x by both sides, and this is again where I get the equation y over x will get me k. So let's just plug in our information. So we have 0.6 divided by 12. It'll tell us what our multiplier is, or our COP. And so 0.6 divided by 12 equals 0.05. Okay, and so, oops, I shouldn't have wrote it there. So 0.05 equals my constant of proportionality. Now, if all the other ones are that, then this actually is proportional. Let's go ahead and test them out, though. Here's my y, here's my x. We do y over x equals k. And so we have 0.95 over 38 equals k. Let's go ahead and do this division. 0.95 divided by 38 equals 0.025. So already, I technically wouldn't even need to do the last two because I already know this is not a proportional relationship because two of them are not the same. Okay, and so really I don't need to do more. I'm done with that one. You could do one more test just to make sure you didn't make a mistake. So let's just test one more. So I'll do my 2.3 over 45, okay, or divided by 45 to see what that multiplier is, or constant of proportionality, same thing. So let's go ahead and test it out. And you remember what is 2.3 divided by 45. And we get something totally different with a 1 repeating equals k. So this is definitely not a proportional relationship. So I can be done officially. Is the relationship proportional? No, because the COPs are different for each point or ordered pair. Okay, all right. So we don't have a constant of proportionality for this. And again, just remember that our equation was y equals k times x. So what times x gets me my y. All right, so now let's apply the same idea now to the graphs. We've sort of been talking about the graphs here. Okay, so two things to know if there's a proportional relationship. You have to have two things true. Your line goes through the origin, and the origin is 0, 0. Okay, and the line is straight, so it can't be curvy. That is not a proportional relationship. It means each of those ordered pairs are not proportional to each other. Okay, so let's go ahead and test these out. We can identify we have x-axis and y-axis. Okay, and so you can test any of those ordered pairs. Just remember that your equation is y equals k times x. Okay, so what times x? Okay, what is that constant proportionality times x that will get me y? And so let's go ahead and test these out. Our independent variable is hours. Okay, just because that's x. Our dependent variable is miles, because that's what our y is. And so we can just test these out and see what the constant of proportionality is. So let's go ahead, and I do see that it goes through the origin 0, 0. Okay, so that's our first good sign. And I also see that it's a straight line. So I already technically know it is because it goes through 0, 0 and is straight. Very teeny writing there. But let's go ahead and find the constant proportionality for this. Okay, and so I'm going to start off just by testing an ordered pair. But one thing I do want you to realize is where x is 1, okay, so I want you to sort of think about this. If I set this up and I say x is 1, we know that where x is 1, that whatever this number is, okay, is also going to be the same as y. So think about that. Where x is 1, if y was 3, for example, 1 times 3 would have to equal 3. So what this tells us is that wherever x equals 1, y will also tell us what the constant of proportionality is, because 1 times that same number equals y. And so that's why they're saying you can just look at that ordered pair to help you know right away what the constant of proportionality is. So that makes sense to start off with that. So look at my ordered pairs. Here's x and here's y. Okay, when I'm at 1 hour, okay, I've gone 30 miles on the Segway tour. Okay, so that means what do you do from x to y? 1 times 30 is 30. Okay, so my ordered pair here is, and this shouldn't be an r, but anyway, 130. Okay, and so whatever x and y is, that y when you're at 1 is your constant of proportionality. So my COP is 30. Okay, let's go ahead and test that out with a different ordered pair. So let's just pick the 2 and 60. So here's my x and here's my y. I know my equation is y over x equals my constant of proportionality. Again, because remember, we have y equals what times x. And so when I divide by x both sides, you get the equation y over x equals k. So that's why we're doing that. Just a reminder again, even though I've told to you like 10 times. All right, so y over x, y is my 60, x is 12, and that will equal my constant of proportionality. My calculator's over here now. 60 divided by 12. We already know what that is, but I'll type it in anyway. And you also get 5, if my thing will move away. All right, and so our 60 divided by 12 equals 5. Okay, so 5 is my constant of proportionality. Okay, and then we can test. That doesn't make sense, right? Because, oh, that's because it's not a 12, it's a 2. So that's why it wasn't working when it should have worked. So 60 divided by 2 is 30, which is now accurate. Okay, so the reason I'm not editing that out of the notes is I want you to see that if something doesn't make sense, when you know it was proportional but you weren't getting the same COP, that should be a red flag to you, like, hey, I did something wrong, okay? And because that typing is so blurry, it left me with a problem. And so I knew that wasn't right, and so I figured out what the issue was. So I'm not going to edit that out, so you can see that it is important to think about what's reasonable as you're doing your work. All right, let's go ahead to a non-proportional relationship. I just know it's not because it's not going through this 0, 0 origin. So instantly no, because the line doesn't go through 0, 0, okay? So it just doesn't have a proportional relationship. But we can go ahead and we can prove it. Let's go ahead and look at our x and always label these. So here's my x and y. So x is kilometers. So km is my independent or my x, and then my dependent is the cost, which is my y. We know that the equation is y equals k times x, or if you divide x by both sides, you end up with y over x equals the constant of proportionality, okay, or COP. Okay, so we can go ahead and test this out. Let's just test out a y and an x. So I need to find some ordered pairs. Let's see, I want to find one that intersects easily. So here's 2, 2 is this one, and I'll do this one, which is 4, 3. Okay, and so remember this is xy, xy. All I have to do is test these out. So 2 over 2, that's my y over x. I also have 3 over 4. If I divide those to test the constant of proportionality, obviously we know this one equals 1, and 3/4 is not going to equal 1. So I just know that these are not proportional. Okay, and so the constant proportionality doesn't exist for this one, but the other one, it is 30. Okay, so that is the basics of how you use the understanding of that equation to find constants of proportionality in tables, graphs, and within equations.